Hey folks, welcome. Today we're going to be looking at adding some nice ambient motion to a Niagara system that we have built inside of Unreal here. We've got this nice flowing particle system, and especially if you're working on a lot of interactive and immersive installations, sometimes you just want to create some nice motion that moves back and forth on its own, create some nice background plates, and that's what we're going to learn to do today. So we've got this Niagara system, and what we want to have it do is use some noise to randomly move it around the screen. Now, the good approach to working with this is to actually take the Niagara system and put it inside of a blueprint. Now, if you're new to blueprints, don't worry, we're going to go nice and slow with this. But one of the great things about blueprints is that they can actually hold all other kinds of components inside of them. So the first thing I'm going to do is right-click on the content browser, create a new blueprint class. I'm going to select actor, and I'm going to give this the name BP_magic. So that we know it's a blueprint for our magic particle system. And what I'm going to do is double click on it to open it up. And the first thing I'm going to do is actually drag and drop my Niagara system into my little hierarchy that I have up here. And you can see once I've done that, we can see my particles inside of my blueprint. And what we can do is save it, compile it, and really quickly even just substitute the existing Niagara system that's inside of our world outliner here. We'll go ahead and delete that. And we can drag our blueprint actor into the scene now. And when we do that, you'll see that we have the same particle system happening, but now it's inside of a blueprint. So we have a lot of ways to script some functionality for it. So what I'm going to do is go back into my blueprint editor here. Let's make this bigger. And I'm going to go over to my event graph. Now I'm going to go ahead and delete everything here. And we're going to start this from scratch. So the first thing I want inside of my node graph is an event tick. So event tick allows us to execute on every frame whatever we want inside of our blueprint. So I know that I'm going to take this output execute pin for my event tick, drag and drop it over here, and we want to set relative location. Now, the really great thing about Unreal is that its node finder has this context sensitive feature. And when it's on, it's always going to try and guess what you're trying to do. And it usually makes your life quite a bit easier. So what we can see here is set relative location and then in brackets n_magic. And if we make this, it's automatically going to make the set relative location function for us and automatically target our Niagara system for us. Now, if you're new to blueprints and you've never done this before, and let's say, you right click to get the search and you set relative location, and you just made any kind of non-context sensitive set relative location function. Well, if you want to wire this up, the first thing to always remember is you want to get your execute pin from the event tick into the set relative location. And when it comes to finding a target, this is where the left side blueprint area becomes really useful, because since we have the Niagara system inside of our component list, down here in the bottom left, what I can do is drag and drop nMagic into the event graph, and I can select get nMagic, which is going to get me a reference to that Niagara system. Then I can go ahead and connect that to my target. Now, the nice thing is, with that context sensitivity turned on, all we have to do is type set relative location, and we can select, set relative location for the nMagic automatically get created for us. Now, the next thing we want to do here is right now the new location is expecting a vector format of data. But a lot of time we just want to kind of work as simply as possible. We don't want to create a whole structured vector just to change some positions. And a nice thing we can do is right click on this input pin and click split struct pin. And what this will do is it'll split the vector into 3 separate floats that we can just connect up however we please. Great, so the only thing really missing from here now is some kind of signal being generated to move those XYZ positions around. So in this case, what I could do is think about how could I control, or generate some random noise. And the first thing I want for that is get game time in seconds. And this essentially gives me a counter that just constantly clicks up as the game is running. And this is important because when you generate noise, you need some kind of input value to generate that noise for you. So with get game time in seconds selected here, I could drag off of its output pin, and I could create a purlin noise 1D. And what that means is using that game time in seconds as a kind of driving value, it's going to generate a new random number for me every frame, and then I can take that number and do whatever I want with it. Now, in some cases, it may be as simple as taking this value and connecting it up to your X, Y, or Z. But one of the tricky things here is our scene is quite big. So if I go back and look at my BP magic and I try and transform it a bit, we can see that actually 1 unit of movement would not move us very far at all. And actually what we want to do here is maybe reorient our object a little bit, because we can see it's slightly off axis with our camera. So I'm quickly just going to rotate this about 45 degrees. And that way my Z and X adjustments of position here are now much better aligned with the camera. But we can see if I go from the kind of left edge of my screen here, which is about -113, over to the right side edge, which is about 745, we're quickly going to see that we need to remap and rearrange our noise values here. So I'm going to hop back into my blueprint, and what I'm going to do is Alt and click on the wire that we have here to disconnect it. And there are a lot of different ways that you can rearrange and remap values. Now, if you are working with any kind of generic value that you wanted to rearrange, I could drag this pin off here and create a map range clamp or map range unclamped. The only difference is that the clamp will make sure it never goes beyond that range that you set, whereas unclamped can go outside of that range. In this case, I'm going to create a map range clamped. And then what we can see is we have all of these settings and parameters that we can set here. So we can set our in range A and B, and then our out range A and B. Now, if you hover over the purlin noise, what you'll see in the comment is that it returns a value between -1 and 1. So I could set my in range to be -1 and +1. And then my out range, we could say we had -114 to about 700. And then we can go ahead and connect that to our X. So now if we go ahead and save and compile this and hit, and actually this is important because when we use set relative location, one of the benefits of this is that it assumes the 0 point is wherever the object is in 3D space. So if actually we moved this object to the left side of our screen, it would use our -100 to 700 starting from that position. Now this is really good and is often the recommended way of doing this kind of thing because it still gives you the freedom to actually come inside of your general editor and world outliner, move things around and rearrange elements inside of the scene without always having to go back inside of the blueprint to set new absolute positions. So we always recommend using these set relative location functions. It just makes it a lot easier and more intuitive for you when you're working. So in this case, I want to make sure that we're kind of back centered up in the middle here, so that when I hit play, we can see now I have this particle system zooming around on the x-axis. Now, from here, I'm going to stop this and go back into my blueprint, because there is another way, especially if you're working with just something simple like a purlin noise. Instead of making a separate purlin noise 1D node and then a map range clamp node, what we can actually do from our game time in seconds is drag the pin off, type in purlin, and we can see there's actually these useful nodes, make, purlin noise, and remap. And this essentially wraps both of those nodes up together into one, where it generates our purlin noise and already gives us a range out min and max. So I can say, you know what, make this range out min and max, and let's say it's -300 to 300. And I want to drag this output pin onto my new location X, save and compile, and go ahead and hit play. And now we can see I have that moving around quite nicely. Now, if I wanted to do the same thing for my Z-axis here, I could use basically the exact same thing, but there's one thing that we have to be careful of. And that's the fact that different purlin noise generator nodes, given the exact same input, will actually generate the exact same value. So if I was to basically copy and paste this exactly as is, and connect this up to my Z, save and compile and hit play, what we're going to notice is it only goes diagonally up and down because it's essentially generating the same values for both directions that we're working in. So one easy way that we can get around that is to just offset one of our noise ranges. So very easily, we can move our get game time in seconds over a little bit, and off of the output pin, I'm going to do an add and do a float plus float. And honestly, you could really add any number you want to this, and just because the two numbers now become different before they go into the make purlin noise and remap nodes, you're going to have different outputs. So I could even go ahead and do something as simple as add 10, and then use the second value that is 10 higher than the first value into the second purlin noise, and that's going to give us, if we save and compile, and play actual unique values on the X and Z axis there. Now, one final trick that you might want to use is if you've never really worked with number ranges like this before, if we wanted to say slow down or speed up the movement of this random noise, it's actually really easy. We can go back into our blueprint, and what we want to do is take our original driving time value, the changing value going into our purlin noise ramps, and either multiply that by a number greater than 1 if we want to speed it up, or less than 1 if we want to slow it down. So let's say, for example, this was looking really too fast and we wanted to make it look a bit more calm and ambient. We can drag off of the output pin. Let's multiply float by float. And I'm going to say, let's make it half speed. So I'm going to multiply it by 0.5 and then use that value to go into the make purlin noise and my plus 10. Now when I go ahead and save and compile and hit play, we can already notice it's moving a lot slower. It's moving half speed now. And if we want to take that even further and say, hey, you know what? Actually, we want it to move super slow, just as ambient as possible. We can multiply that by 0.1, compile, save, and hit play. And now we can see it's moving ever so slowly around the screen. So hopefully that helps get you started creating some nice ambient movement using random noise ranges inside of a blueprint with whatever you're working on. Today we got to use a nice Niagara system, but you could use this with any kind of 3D geometry, with lights, basically almost any actor that you would put into your regular scene, you can add inside of a blueprint and take control of like this. Hey guys, thanks for watching. If you're serious about taking your touch designer and interactive skills to the next level, I highly recommend you check out the Interactive and Immersive HQ Pro. It's the only educational resource and community of its kind for touch designer and interactive professionals. You can learn more by checking out the link in the description. And if you like this video, don't forget to hit that like button. And if you're new here, don't forget to hit subscribe and the little bell icon for more awesome free content.